Hey, good afternoon, biology students. Say, I've been working on going through your notes, and there are quite a few students who are having some difficulties applying Chargaff's rule. So I wanted to take a couple of minutes to just review what this application really looks like. So let's start here. When you look at a DNA molecule, and actually when Erwin Chargaff looked at a DNA molecule, the work he did was recognizing that the amount of adenine is always the same as the amount of thymine in any DNA sample. So whether you're looking at the DNA of yeast or bacteria or humans or dogs, when you look at the whole sample, so we'd call that 100% of the DNA, and then you specifically look at how many adenine bases there are, you will always find similar amounts of thymine bases. The same goes with guanine and cytosine. So whatever percentage of the sample is guanine, you'll have an equal percentage of cytosine. So with that being said, I'd just like to go through this example in the notes here. So this was applying that rule where the amount of adenine is always the same as thymine. So if you have 31.5% of your whole DNA sample, the whole sample would be 100%, is adenine, then thymine is that exact same amount. Look at my skills. Oh man, I messed up. Right? We would have 31, back to the pen, there we go, 31.5%. Man, I guess I should have practiced, huh? 31.5% adenine and 31.5% thymine. That's what Chargaff's rule states. You will have the same amount in both of those. So then when we get to guanine and cytosine, we have some additional calculating to do. So when you take a look at adenine and thymine, that takes up, if you add the adenine to the amount of thymine, that takes up a chunk of the DNA. We already know adenine's 31.5% of the DNA. Thymine is the another 31.5%. So we can add those two together. And so adenine and thymine account for, so 31.5 plus 31.5 is 63% of the DNA. So what we need to do then is figure out, well, that's 63% of the 100%. So if I remove that, because I've already accounted for that DNA, then what's left over? 100% minus 63%, we'd have 37% is left over. So between guanine and cytosine, we get to split that 37% in half. So I'd take 37 divided by 2. Okay. So again, I'll just put up here the amount of adenine equals the amount of thymine. Whoa. The amount of guanine is going to equal the amount of cytosine. Well, that should be an equal. Oops. Okay. So again, we take that 37 and divide that in 2. So here we'd have 18 and a half and 18.5%, because the leftover 37% is just split in 2. Okay, so let's take a look at sample number 2. If we have 30% of the sample is 30% is thymine, then we know that adenine equals thymine. The percentages are the amounts. So I could just put in my 30 there. Oh, and looky here, when I come over to guanine, 20% is guanine. So then these two equal each other. So 20% is then cytosine. Sweet. All right. And then lastly, let's take a look here at our last sample. Okay, so it's giving us 17% is cytosine. So I know 17% then is going to be how much guanine we have. These are always equal to each other, as are adenine and thymine. Okay, but now I only know how much guanine and cytosine there is so far. So when I add these two together, then I get 34. I have 34%. 17 plus 17 is 34%. So I have 34% of that sample accounted for. So if I take and subtract that number from 100, 100% is the whole sample. So I have to figure out, all right, then I need 66% of my sample has not been accounted for. That 66% is evenly split between these two. So I can split that in half. 33% of the sample will then be adenine and 33% of the sample will be thymine. That is how you apply Chargaff's rule. If you have further questions, please let me know. You can shoot me an email or comment on the notes that you're working on. I hope that was helpful.